Hey guys, today we're going to be taking a look over how we can differentiate infinite series. And this may seem pretty much of a shocker since we don't really think about differentiating infinite series, but I can assure you it's not as hard as it seems. So in this video, I will not only explain how to take the derivative of these infinite series functions, but I will also be sharing you some ways that I solve derivatives. In my personal experience, you should never solve a derivative unless you have absolutely simplified your function. When you have completely simplified your function, then feel free to take a derivative. And I will display these concepts with a few questions on my own. So why don't you come and join me and we will start learning together. Okay, so we have our first problem here. So we have y equals x to the power x to the power x to the power x infinite times. And of course, we can see why this is an infinite series. Well, because we quite literally have that infinity right over there. So how do we approach these problems? If you want to give this problem a try, feel free to pause the video and give this problem a go. But for those of you who have no idea how to solve this, no worries. So in order to solve this, don't start taking the derivative just yet. We can actually simplify this by a ton. And by a ton, I mean you can completely get rid of this infinity if you simplify it. Let me show you how. So we know y is equal to x to the power x to the power x to the power x all the way up to infinity. So we could say that this thing right here, it looks really familiar, the one that I've circled in black. And what do you think that is? Well, if you said that it's y, then you're completely right. Because we know from the original problem that they gave us the value of y. They said y is x to the power x infinite times. And this thing that I circled right here, that's also x to the power x to the power x infinite times. So we could rewrite this saying that y is actually equal to x to the power of y. And just like that, we've completely eliminated the infinity sign altogether. It's just a matter of realizing what they gave you and seeing if you could simplify this in order to get rid of that infinity sign. And now that we've gotten rid of that infinity sign, we can solve this as we normally would. And how usually I like to take derivatives or find dy over dx, we're supposed to find dy over dx. And in order to do that over here, you could just go straight head on. You could just solve the derivative right over here. But what I like to do, I don't really like this x to the power of y. I'm not really a fan of having something to the power of something. So I'm just going to take the natural log of both sides. And you will see why in a second. So natural log of y is just going to be natural log of y. And then we have natural log of x to the power of y. And if you remember, if you have something to the raised to the power of something, that something comes in front when we're dealing with logs. So right now I haven't taken the derivative yet. I want you to realize that I have not taken the derivative yet. I'm just simplifying it. So when I take the derivative, it's going to be a little bit easier. So now we have natural log of y is equal to y natural log of x. So I just brought this y to the front. Now I can't really simplify this anymore. So I'm going to start taking the derivative. So we are taking the derivative with respect to x. So remember implicit differentiation. Left side is going to be 1 over y dy over dx. Right side, we're going to apply the product rule. So I'm going to take derivative of this first, which is 1 over x. So y times 1 over x, which is just y over x. And then we have plus natural log of x, derivative of y, which is just dy over dx. Let us start to isolate dy over dx over here. I'm going to take that right over there. So dy over dx, 1 over y, minus natural log of dy over dx, and that's equal to y over x. So I just took this to the other side. Taking dy over dx out from both terms, we are left with 1 over y minus natural log of x. The right side stays the exact same, so we have y over x. And now let us simplify the left side. So the left side is 1 minus y natural log of x over y. I just took the same denominator. Right side, once again, that stays the same. We have dy over dx. Let's cross multiply. Y goes on top. We have y squared over x times 1 minus y natural log of x. And just like that, we have found let me get a highlighter. We have found dy over dx from an infinite series. Now, as you saw, that wasn't too difficult. The main step was right in the beginning when we eliminated this infinity sign. And we're going to see more problems just like this one right now. So in this one, we also have to find dy over dx. And now, since you know what our first step will be, I encourage you to pause the video and give this problem a go and come back to check your answer. Okay, so I'm going to go over the answer right now. So once again, we don't really like this infinity sign. We want to get rid of it entirely. In order to do that, we see this part right over here is the same thing as y. Y is root sine x plus root sine x plus root sine x. This is also root sine x plus root sine x plus root sine x, all the way to infinity. So we could rewrite y as square root sine x, and that's in parentheses, plus y. And now that we got that, we eliminated the infinity sign. Now we can start taking the derivative. But once again, I don't want to take the derivative just yet. I always like to simplify my functions first before I take the derivative. That way, when I take the derivative, I don't have to do all that messy algebra. So I see that I have this square root. I don't really like the square root. I'm just going to square both sides. So I have y squared is equal to sine x plus y. And this seems to be simplified enough, so I'm just going to leave it like that. Now I'm going to start taking the derivative. This way, I don't have to do any chain rule if I just took the derivative up here. Now I could start taking the derivative over here. Once again, we're finding dy over dx. We're taking the derivative with respect to x, so there's going to be implicit differentiation over here. So you have 2y dy over dx is equal to derivative of sine x is cos x. It's very important to remember derivatives of trigonometric functions, even though we don't like memorizing them. And then plus derivative of y, that's just dy over dx. Taking dy over dx to the other side, we get 2y dy over dx minus dy over dx. Right side, I'm just left with cos x. Let's take this over here. Taking dy over dx out from the left side, we are left with dy over dx. 2y minus 1 is equal to cos x. Now, dividing both sides by 2y minus 1, we're left with cos x over 2y minus 1. And that over there is our derivative. Okay, now on to our next problem. Over here, we're also finding dy over dx. And once again, we have an infinite series. We have infinity at the top. So how are we going to solve this? So just like the previous two problems, we're going to see if we can replace something over here with y. So we know that y is e to the power of x plus e to the power of x plus e to the power of x. And we see that this part right over here is the same as y. Y is e to the power of x plus e to the power of x plus e to the power of x. This part over here is also e to the power of x plus e to the power of x plus e to the power of x to infinite times, of course. So this is also y. So we can rewrite y as e to the power of x plus y. And you need to be careful over here. This is not e to the power of x plus y like this. You need to realize that when you're adding it to the exponent, not to the original term. So y is going to be in the exponent. So let me just erase that over there. Now we can get on to simplifying and then solving the derivative. It's always important to simplify your functions before you solve for the derivative in order to make finding the derivative at the end much easier. So what I like to do whenever I see a power, I think just take the natural log of both sides. So I have natural log of y is equal to natural log of e x plus y. The right side is equal to x plus y natural log of e because I took the power down. Next, I have natural log of y is equal to x plus y because natural log of e is just 1. Now I can start taking the derivative. So the derivative of natural log of y, once again, we apply implicit differentiation. That is 1 over y dy over dx is equal to 1 plus dy over dx. Taking this over here, let us take this part over there. So that's 1 over y dy over dx minus dy over dx is equal to 1. Let's take dy over dx out from the two terms on the left side. We're left with 1 over y minus 1, which is equal to 1. We left the right side the same. dy over dx, simplifying the thing in brackets, we get 1 minus y over y is equal to 1. dy over dx is cross multiplying, y goes on top, so y over 1 minus y. And that is our derivative. So now let's move on to the last problem for this video. This is somewhat of a tricky problem, but the concept is still exactly the same. Okay, so let's see what we can do over here. Once again, we're finding dy over dx. We're finding dy over dx. Now we just need to get rid of this infinity. And once again, how we get rid of this infinity is that we try to replace something in here in terms of y. So we know y is equal to sine x over 1 plus cos x over 1 plus sine x. But I'm just looking at the gist. Sine x is going to be on top. That is what y is. So I see that over here, sine x, the next time sine x is on top, that is right over here. Sine x is on top right over here. And that is over 1 plus cos x. Okay, that aligns with what we said previously for what is y. And over 1 plus all the way to infinity. So y in this case is sine x over 1 plus cos x over 1 plus y. You can probably guess why this is a bit more confusing than the other problems we've done. It is because finding y in this one was very critical. In this case, y wasn't up here, y wasn't down here. Y was actually all the way over here, which is different from the other problems because we were able to find y pretty quickly in those problems. So this part is y. Y from the problem, they gave us sine x over 1 plus cos x over whatever. This is also sine x over 1 plus cos x over whatever to infinity. Now, I do not want to take the derivative of that, so we're going to start simplifying and then take the derivative. So let's simplify the denominator since that looks a little bit hard to solve. So we have sine x over 1 plus y plus cos x over 1 plus y. This denominator goes to the top. We're left with y is 1 plus y sine x over 1 plus y plus cos x. Let me write that a little bit neater. Plus cos x. Let us multiply this bottom part to the left side. So this will result in y times 1 plus y plus cos x equals 1 plus y sine x. Now I'm just going to expand everything. So left side will be y plus y squared plus y cos x is equal to sine x plus y sine x. Now it seems that I've simplified everything. So now I'm going to take the derivative. So derivative of y, remember, implicit differentiation, Derivative of y is dy over dx plus 2y dy over dx plus chain rule. So, product rule. So this will be dy over dx cos x minus y sine x, because derivative of cos x is minus sine x. And that, I don't have enough space. We're going to say that is equal to derivative of sine x. That's easy. That's just cos x. Once again, we apply product rule again for this term right over here. Derivative of y is dy over dx times sine x plus derivative of sine x is cos x, y times cos x. All right, now it seems that we have everything. We need to take the dy over dx to one side. So all these terms have a dy over dx, and this term has a dy over dx. Let's take those all to one side. And I'm actually going to do this in one step. I'm going to take dy over dx to one side, and I'm going to take it out of all the terms. So dy over dx, 1 plus 2y plus cos x minus sine x is equal to y sine x plus cos x. Okay, let's do a new page. Plus y cos x. So what I did, I took this to this side over here. This is the equals to sign. Let me make that a little bit bigger. Equals to sign. And I took this part, I took this part to the other side. then I took dy over dx out, and I took this to the other side of the equals to sign. And that becomes a positive, which is what I got over here. And these two terms just stayed the same. Now I can find dy over dx. We're left with y sine x plus cos x plus y cos x over 1 plus 2y plus cos x minus sine x. And that is our answer.